Okay, so iNZight for bivariate data. Obviously, you would run iNZight in the normal way. Okay, find it on your computer, run it, and then you're obviously going to need to import some data in the usual way. Import data, and to find the data for these 8 data sets, you need to go to Student Drive. And then go to Stats, and it's under J. Will's data sets, because it was all produced by a guy called Jake Willis, or J. Wills, rather. So, Maths, and then under 13 Stats, and look for J. Wills bivariate data sets at the bottom of my screen. Now, depending on what one you're interested in, I'm going to choose babies. Depending on what one you've done the most research for, I'd like you to choose that particular data set. Click OK, import the data. Okay, now where last internal we looked at advanced and we clicked on time series, we're actually going to just look at a scatter plot. One thing to do before you go and produce your scatter plot is to look at a scatter plot matrix. Now, before I go there, I have to highlight the variables. So view variables. Okay, and those are all the variables that relate to the baby data. And if I hold down, hold down the shift button, I think it is. No, control button. How do I highlight all of those? Maybe if I just try going advanced scatterplot matrix. I've got to highlight all these ones. There we go. Okay, so if you highlight all these variables, which are the same variables as over here, and click plot, you get all the possible combinations of all the graphs. Thank you. Turn it off. Whoops. Come back. Okay, so if you look down here on the diagonal, you can see all the variables. So this graph, let's look at that graph there. Can you see where the mouse is? That graph there is birth weight versus gestational age. So in other words, how many months, or it might be weeks in the womb compared to the birth weight. So that's 2 variables compared with each other on a scatter plot. This graph here is birth weight compared to fasting blood glucose. Don't know what that is, but still a variable. Okay, and to me there aren't a lot of relationships between those 2 variables if I scan my eyes across. Okay, so I might have chosen a hard one to look at, but if I get out of here now, I think it's, maybe just minimize, and go back to here. To actually create one of those scatter plots, you click on the variable you want and you drop it here, say, birth weight and gestational age was one I was interested in. And it should come up over here. Maybe if I change, which one do you think would be the independent variable, birth weight or gestational age? The one that you control. Yeah, possibly. It's a bit of a tricky one. Now, I think actually on a different screen. Why is this not working? What happens if I close that? Close. wonder why it's not coming up. Close. Here we go. Gestational age and birth weight. So on this particular graph, I've put the gestational age, and I need to go. It looks like it's in weeks. 40 weeks is sort of the average gestational age for a baby. And birth weight, this must be in grams, 4,000 grams or 4 kg. And there is some sort of relationship. The longer it's in the womb, the heavier it's becoming. Now, so all you really need iNZight for is this, for achieved, is this graph. And from here, you need to add to the plot. Trend curves. Click OK. And we want a linear. See there it says linear. Okay, all we want at this stage is a linear line. Remember, I'm just talking about achieved. So click OK. Get rid of that. Okay, and to get the equation of that line, you click Get Summary, and you definitely, because remember, statistics in general is all about making predictions, and so we analyze data to make predictions about, in this case it's going to be a prediction about birth weight given you know the gestational age, and you need the equation of the line to be able to do that. Okay, so part of the analysis is going to be making a prediction for say 40 weeks. So you put 40 into the equation, multiply it by 156, and subtract 2,757, and you would end up with a birth or an estimated birth weight. We have yet to talk about what the correlation of 0.4 means. In short, the closer correlation is to 1, the better the model is, or the better fit. In fact, I'll show it to you on here. Here they are. Okay, so you can see all the correlations with correlation 1. Correlation can also be a negative number, as large as -1, but the correlation that I was looking at was about 0.4, and hence quite a broad scatter. 0.8, stronger relationship. 1 is a perfect relationship, and in reality there aren't many variables with a correlation of 1. In fact, it's impossible. Okay, because that's saying there's
maybe weight of gold and price, because it's fixed.
Yeah, I suppose if it's a perfect relationship, you could get, but in terms of measurement, it's very near impossible to find a correlation of 1. So usually they're 0.9, 0.8, 0.4 is a weak correlation. Okay, let's just pause that. How do I do that?